Alrighty. So let's go through this bell work. This is using exponent laws. So on this first one, what we have is that these two pieces are being multiplied together. So this is the same thing. Since everything's being multiplied, those parentheses aren't actually doing a thing. We can rearrange it to be a cubed times a to the fourth times b squared times b cubed. And just make those all multiplications. Since they're all being multiplied together, it doesn't really matter. 2 times 3 times 4 is the same as 4 times 3 times 2. Doesn't matter what order it's in. And then we can use that information to kind of combine these pieces together. Because if I have a to the third times a to the fourth, how many a's do we really have here? It's not going to be 12. 7. Remember, a cubed, I could write that as a times a times a. And b to the fourth, that's b times, or not b, oof, a times a times a times a. So it gives me 3 a's and 4 a's, which gives us a grand total of 7 a's. So we're going to wind up with a to the 7th and b to the what? Oh, 5th, yes, thank you. I was staring at the this piece and going, not 5. That's not b's. Down here, this is powers over powers. So again, if it helps you to rewrite things, you can rewrite this one like in the style of the first one, where we take x to the fourth times y cubed times itself. It doesn't work super great for when it has higher orders, but we can do this to see the pattern. So if we have x to the fourth y cubed times x to the fourth y cubed, because that's what it means to be squared, in the same style as above, how many x's do we have? 8. So we're going to have x to the 8th. How many y's do we have? 6. So if we look back at the original one, over here, what did we do with the 4 and with the 2 to get to 8? So if we skipped this step, so what if this was 12 and not 2? I wouldn't want to have to rewrite this 12 times. Ugh. So let's figure out what happened here. What happened to 4 and 2 to make 8? Multiply. Same thing happened between the 3 and the 2. So when we have it raised to a power, we multiply them. So you can absolutely write them out the long way, but sometimes they gonna get real long. And that's a lot. So it's easier if we can notice the pattern and notice, especially on the next one, we're going to take this 4 times all the exponents of all the pieces here. So this last one kind of combines everything together. We're going to have 3 times our m to the fourth n cubed. And when we bring in that 4 power to get everything down to be a product, we're going to have 2 to the fourth, m to the 3 times 4. 3 times 4 gives us 12. And n to the 8th, 4 times 2. Then we're going to do just like we did on the first one, where we combine our like terms. So we're going to have our 3 times 2 to the fourth. What is 2 to the fourth? 2 times 2 times 2 times 2. 16. We're going to have 3 times 16. M to the fourth and m to the 12th. We're up in this kind of zone. M to the 16. We're adding them together. And then we're going to have n to the Bless you. I've got n cubed and n to the 8th, 11. So our last piece to simplify this is we got to come back here and multiply 3 times 16, which is going to be 48. Yes, ma'am. That would be 12 plus 4. The exponents on the m's. Sorry, trying to zoom in. It's not letting me change it. It was this 4 and this 12.
So where'd you get the coefficient of the x? Yeah, that one. Oh,
This is 2 to the 4th. This 16? 2 to the 4th. We got to bring that power into the number 2. Even though it doesn't have an exponent written here. Whoop. It has an invisible 1. Everything has a 1 exponent, so we've got to take it to that exponent as well. Because if I was to rewrite it like we did here, I would have a 2 in the front of each of those. 2 times 2 times 2 times 2 for each of the 4 times. Okay, so and that's a really common mistake, is that we forget the number inside these. So our final answer here is that 48, M16, and the 11th. And I'm getting rid of that because I hate that. There we go. Okay, so this is old school, old school, old school. This is an Algebra 1 thing. It's been a hot minute since we did exponent laws. But we got SAT coming up in like a week for some of us. So we're going to go through some old stuff just to kind of refresh and get us ready for that. So all my juniors are going to be taking SAT like next week. So, boop. All right. So what we're going to do today is we are going to not be graphing. Yay! So we're going to be headed in an entirely different direction, and we are going to start manipulating logs and playing with them. I'm sorry, I have like something in my eye, and it's driving me nuts. So what we're going to do today is we're going to start with some properties of logarithms. So we're going to have 3 properties, and we're going to work with these 3 properties for a long, long time. And I'm going to write them out with you just so that we don't have to take forever. So these are going to be really generic, so they're going to be really, really lettery. Just know that now. For the most part, when we work with them, they're going to have a lot less letters. So if I have some log with any base, it doesn't matter. And inside, I have 2 terms, x and y. That is chonky style. Holy cow. We can rewrite this and separate them apart as log base b of x plus log base b of y. So we can take things that are written as multiplication and separate them into addition. So then we're going to have something called the quotient property, which is very similar to the product property, but instead of them being multiplied together, quotient means they are divided. So if I have something being divided by something else, so some sort of fraction, we can split that apart to be 2 different pieces, but instead of being addition, we're going to make them be subtraction. Log base b of y. And then our last property that we're going to work with is a power property. So if I have some logarithm, some base of two pieces, and we just tend to use x and y just because it's familiar letters, we can take this power and actually put it in front as a coefficient. So it can be y log base b of x. So we're going to have that multiplication becomes addition, division becomes subtraction, and powers come down and are multipliers. So it kind of knocks everything down a level in structure. And we are going to work with these a bunch of cruncha over the next like 2 weeks. We're going to be using these properties a bunch. So you're going to need to know them. I don't know that we need to go so far as like flashcardy things, but we're going to use them enough that we're probably going to wind up with these others memorized. Okay? We're going to need to know how to use them. Because what we're going to do is we're going to take logarithm statements, funky looking things, and we're going to go, all right, we're going to make this thing as big as possible, and then we're going to take really, really big ones, and we're going to smush them all back together so that we can use things in different spots to help us with stuff. So we are going to play with logarithms like they are made of weird Play-Doh. So in order to do that, we need to have some steps to solve. So this is we're going to have another page of writing stuff. I know, I'm horrible. So we're going to start with expanding. We're going to take logarithms that are very, very small, and we are going to blow them up into teeny tiny pieces like they're made of confetti. So we have some steps we're going to follow. Our steps to expand, we're going to take, oh my gosh, I just totally brain farted, and I am forgetting the order I'm supposed to write down. Give me a second. My brain just like stopped working because it's 7 o'clock in the morning, and I don't want to give you guys stuff in the wrong order. Where did I put the book? I love that. So much fun. Got it. That's semester 1. Oh my gosh, I love it. I go wandered up. So much fun. Okay. There it is. Got it. On page 36. I just don't want to give you guys wrong. I'd rather have us take a few seconds here and have me not confuse you guys. So. I want. Got it. Properties. Steps. Got them. Ha-ha. Cool. Yep. See, I had one of them swapped in my head. That's why I looked. I knew something was off the way I wanted to write it. So, our first step that we're going to use when we expand is the first thing we're going to do is that division becomes subtraction. So if you see division anywhere in our problem, the first thing we're going to do is switch it into subtraction. We're going to split it into two pieces. Our next step is that our multiplication, anything that's multiplied, is going to become addition. And then our last step is that powers come down as coefficients. Or sometimes you can think of it as like a multiplier. Either way is fine. Whether you say coefficients or we say multipliers, either way. But we're going to do division, then multiplication, and then powers. Oh, of course, naturally, I had it typed on the next page. I have to look on the next flipping page in my slideshow. It's typed on the next page. I love that for me. I make such fun choices sometimes. Okay, so we're going to be working with these today. We're going to work with them bunches and bunches and bunches. So when we're working with expanding and things like this, I'm going to give you problems that look like this. Oop, hang on. Like this. There we go. This is 3 separate problems. So we have one here, and one here. And we're going to follow our 3 steps to make them as big as we can. So if I have log base 2 of 5 times y, we're going to look at this and we're going to say, do I have any division in here, in this piece? Do we have any division? No. Do we have any multiplication? Yes. Between the 5 and the y, it's multiplied. So I'm going to take this and we're going to break it into 2 separate logarithms. Log base 2 isn't going to change. So we're going to have log base 2 of 5. And then the multiplication turns into addition, and we put another log. Log base 2 of y. We do this because things like this, log base 2 of 5, that's a number. It's a gross number, but it's a number. It's just numbers here. This is where our variable is. So what we're doing is kind of isolating our letter in a really weird way. That's our answer. I can't do anything further. We do not have any exponents in here to make into multipliers. So this is our expanded form. That's our answer here. So we're going to put it into more log pieces. We're trying to get as many pieces as we can. So on this next one, we have an x and y, and we have log base 3. This is division. So division is going to become subtraction. So we're going to split it apart. So we need to split this into 2 pieces. What is going on with those arrows? That was weird. Fine, let's do half arrows. So we're going to have log base 3 of the numerator of the top minus log base 3 of y. Top minus the bottom. And again, I don't have any multiplication left in these pieces. And I don't have any powers on these pieces. So for this one, these are as expanded as we can go. That's our answer. On this last one on this page, I don't see any division. I don't see any multiplication. But I do see a power. This 3 is an exponent. So what we're going to do is we're going to take our power down and it becomes a multiplier out in front. So this one we're going to rewrite as 3 log base 4 of z. Since we didn't have any multiplication or division and we don't have any more powers, that's our answer. So each of these only had one. They're not all going to be like that. But questions on these first three where we've kind of played with this a little bit. Yes, ma'am. Yes, let me write your pass. I'm going to put the next one up there. So here's our next one. We've got a few pieces. All right. So I see a lot of pieces in here. Step number one is to take division and make it multiplication, or make it subtraction. I do have a division here. So my first step is going to take my numerator. So we're going to have log base 3 of 5y. And we're going to subtract log base 3 of x to the 4th. So step one is that division becomes subtraction. So we took our division and made it subtraction. Then we need to check for multiplication. Step two is anything that's multiplied together becomes addition. Well, I have a multiplication here. In between these two guys, in between my 5 and my y is multiplied. So we need to split this apart into a couple of pieces. So we're going to put log base 3 of 5 plus log base 3 of y. And then we're going to bring down our log base 3 of x to the 4th. So we've done that our division becomes subtraction. We've done our multiplication becoming addition. 5 times y became log 5 plus log y. Our last piece is that our powers need to come down and be multipliers. I don't like how close that is to these. Let's do that. Powers are going to come down and be multipliers. So I only see one exponent here, this 4. So what we're going to do is this 4 comes down and is a coefficient in front of the log. So the first two aren't really changing. They don't have any exponents. So we're going to have log base 3 of 5 plus log base 3 of y minus 4 log base 3 of x. When we are done expanding, there should be no more exponents, and each log should only have one thing in it. Log 5, log y, log x. They only have one term inside. So each log should have only one term, and it shouldn't have any exponents. My iPad's about to die, so I'm gonna come back here. Okay, questions on this one, because this is the first one that we had that kind of combined things together. Okay. We're going to do a couple more. So here's our next one. So our first step is to see if we have any division. Division becomes multiplication is first. Do we have any division in here? Oops, sorry. I don't see any division in here. But I see a bunch of multiplication. So we checked for division. We don't have any, so we're good to go. So no division. Multiplication becomes addition is going to be our next thing. And I have multiplication here, and here, and here. So we're going to split this up, and we're going to wind up with 4 different logs because we have 4 terms here. So we're going to have log base 2 of 4 plus log base 2 of x squared plus log base 2 of y to the 8th plus log base 2 of z. Ooh, sorry, I wrote smaller than I intended. I'm going to change the view real quick just so it's not quite so small. My pen went super skinny and I did not realize it. All right, so we've done our multiplication becomes division. Our next thing is that our powers come down to be coefficients. So we're going to come in here into any of these statements that have exponents, and anything that has a power, it's going to come down and be a coefficient. Anything that has a power is going to come down and be a coefficient. So we're going to rewrite our log base 2 of 4 doesn't change. And then we're going to have 2 log base 2 of x and 8 log base 2 of y. Oh, sorry. And log base 2 of z. Each log has only one term. I don't have any exponents. I don't have any operations inside my logs. So that one is fully expanded. So this is our answer. Imagine how bored someone had to be to figure this out. One more. Okay, we're only doing one more of these today. It's got a lot of pieces. I'm going to zoom it in so you can see it better. Log base 5 of the fraction that has 9v to the 5, b to the 5th, over y squared, w to the 4th. All right, now I'm going to zoom it back out. All right, so our first step, division becomes subtraction. So where we have this fraction, is going to become subtraction. So we're going to have log base 5 of 9v to the 5th minus log base 5 of y squared w to the 4th. And there's one tricky part in this one that we're going to need to watch out for, which we'll get to here in just a second. So we just need to be really careful because we need to make sure we maintain that we're subtracting this whole chunk. So our next step is that our multiplication becomes addition. So any place we have multiplication, they're going to add together. We just need to be really, really careful because, again, we need to make sure we're subtracting this whole chunk. So I'm going to put parentheses around this right-hand side when we expand it again. Because I need that whole chunk to stay subtracted even though I'm about to put a plus in here. So we're going to have log base 5 of 9 plus log base 5 of v to the 5th minus, and I'm going to put a set of parentheses here, log base 5 of y squared plus log base 5 of w to the 4th. So when we have subtraction that we're then going to split, we need to add a set of parentheses because of the minus sign. We are going to get rid of the parentheses here in a second because we're going to take that minus sign and distribute through it. Distribute it through. We just need to make sure that this term winds up with a minus sign in it because it's in that denominator. So our last step here is that our powers are going to become multipliers. And at the same time, I'm going to distribute this minus sign through because I don't want to have to rewrite it a whole nother time for that. So our log base 5 of 9 doesn't change. This guy hangs out. Then we're going to have this 5 is going to come down and be a coefficient. We're going to have 5 log base 5 of v minus, this 2 is going to come down, 2 log base 5 of y. And this is one that's going to be the hardest one. We're taking this minus sign in, and we're going to bring the 4 down. So it's going to be minus 4 log base 5 of w. And these are weird and take some practice to get used to, especially. This is our our fully expanded answer. The reason we have this expanding is because to try and calculate, when we get to the calculation part, trying to calculate this is super duper gross, whereas each of these individually is way less difficult to calculate. So the reason we have it is so that when we get into solving things, we can kind of do a zoom in and say, all right, what's this piece, and then what's this piece, and what's this piece, to then combine it instead of going at the gross fraction at the top. Okay, so we have this so that we can break them down into tinier chunks that are easier to work with. Tomorrow we're going to work with all these properties again. We're just going to go the other direction. So I'm going to give you big long ones, and we're going to shrink them back down into the teeny tiny single log. It's called condensing. So what we're going to do is I'm going to give you homework 8-2. It has expanding and condensing and some solving. So this is for today and tomorrow and Monday. Okay, so we're going to work on this one for a while. What's up? Oh, okay, I thought you had a question. All right, so I'm going to pass this one out. We actually did stuff for number 2 today. Tomorrow we're going to do all the stuff for number 1. It's not super different, it's just going the other direction. So we're going to work our way up our list instead of down our list.